Okay guys, Mr. Bennett here. Today we're going to just be looking at the nuclear fission reactor. This is just one type of nuclear fission reactor, and this is probably the one that you need to be able to talk about in terms of the process of fission and how it all works. So generally the nuclear reactor has what we call a core, okay, the nuclear core, and that's actually quite well protected in terms of if you have a meltdown or something like that. It's supposed to be able to contain the fission products in there so they don't leak out into the environment. But you can see this part of the system in here, this green part in here, is in fact, and I might just use a pen so you can see what's going on, what I'm talking about. Okay, so if we go, and I'll use a highlighter, make that yellow. So in here, so this part of the nuclear reactor through here is a closed system. Okay, so what happens in here, you've got your fuel rods, you've got your control rods, which are made of boron and cadmium, right, to try and actually absorb the neutrons. So this is where the nuclear fission reaction occurs. So you have a vessel which basically keeps this pressurized, right? None of this particular part of the system will actually ever escape. Right? That's the idea of that. It's a controlled system. And obviously this is the big building you see, concrete and all that sort of stuff. Now you might actually see steam coming out of a nuclear power station, but that's to do with this part of the circuit here and not this part of the circuit which is contained. Right? So in here what happens is you need to be near a water source. Okay, so you bring your water in here, that gets heated up by this particular pipe, alright, so that's going to get superheated. Then what happens here is you produce steam. The steam goes through the turbine as a conventional power station does, where instead of using nuclear fuel it uses things like either gas or coal or something like that. So then as that goes through the pipe, the steam goes through the turbine, turns up. You have an external water source here, right, that actually is used to condense the water and cool that down, and then that water then gets cooled and pumped back through the pipe again into here, which produces steam. So that's again like a sort of a sealed system, I suppose. And so therefore you're actually having a cycle there. Now what happens here is that water pumped here gets pumped out through the pipe, and so therefore that gets cooled in like a local lake or the sea or whatever. Eventually that water is going to be raised in temperature by a little bit, so there can be some negative effects, like it can actually raise the temperature of the water source out there, and so that if you raise or change the temperature there, you can actually change the ecosystem. So there are some dangers there with that. Alright, so essentially in here you've got, like I said, you've got your core, which you've got your fuel rods, you've got control rods which go down there, and obviously most nuclear power stations have like a shutdown thing. So let's say there's something majorly happens, you've got control rods, but they also have emergency rods which will also go down and shield between the fuel rods. Alright, so obviously if you want to speed the reaction up, what you do is you lift these control rods. If you want to slow the reaction down, you lower the control rods. That's your particular type of thing. So generally this big container here is made of a couple of feet of concrete. You might use lead or steel to actually also reinforce that and help shield. Right? So it's actually a pressurized vessel there, contained system. You've got this system which is open to the outside, but this one here also is another contained system to try and actually produce electricity. So not really all that much different from a conventional power station how it works. It's just the heating of the water that's a little bit different.